Students, digital transmission की discussion चल रही है. We have seen as to how the digital data is converted to a digital stream or a digital signal. फिर हम लोगों ने ये भी देखा कि using the process of digitization, how we convert the analog data into digital data so that it can be transmitted as a digital stream or a digital signal once again. Now, students, in the case of digital transmission, an important topic is that of the transmission modes. When we are talking about the transmitting of data from one point to the other, there is a issue that is of primary concern, and that issue is that of wiring. What wiring to be used? And students, the wiring used depends on the data stream. Students, what do I mean by data stream is that we need to decide if we send one bit at a time. Do we send multiple bits at a time? Do we send a stream and then stop? Do we allow the synchronization to happen using some specific combination of bits? Or do we allow the synchronization to happen using timing at both ends? Students, on a high level, we have got two transmission modes that we are going to be talking about. The first one is called parallel transmission, and the second one is called serial transmission. Students, as you can see on the slide, we have got two basic modes of transmission. The first one is called parallel, and the second one is called serial. And then there are further three types of serial transmission. They are asynchronous, synchronous, and isochronous. Students, the basic definition, the difference between the two, parallel and serial, is that in the first case, we send, as the name indicates, we send multiple bits with every clock tick. In the case of serial, we send only one bit with every clock tick. And then you have got three different types of serial transmission that we are going to be talking about. अब स्टूडेंट्स, सबसे पहले बात करेंगे पैरेलल ट्रांसमिशन की. स्टूडेंट्स, जैसा कि मैंने आपको अभी बताया, पैरेलल ट्रांसमिशन के लिए वी ऑर्गेनाइज द डेटा इन द फॉर्म ऑफ n bits. And when we divide this data in the form of n bits, then we send all those n bits at the same time with a clock tick. Students, what this means is that we need n number of wires from point A to point B. Parallel transmission means we have n wires running from the sender to the receiver, and we are using those n wires to send n bits with every clock tick. If you would have you would think about or imagine a simulation, it means that there are 8 wires running from A to B, and with every second, if that's our clock tick, with every second, n bits are sent. With every single second, n bits are sent from the sender to the receiver. Now, students, as I told you, n wires are required in this particular case. In the slide, what you're looking at is a sender, and we have got 8 wires in this particular case. So the value of n is 8. Now, the 8 wires are capable of carrying 8 different bits, and these 8 wires in this particular case, we need them to be up and running from the sender to the receiver all the time if you are going to be sending 8 bits at the same time. Otherwise, there will be a loss of bits in there. Students, some advantages of this transmission mode, the parallel transmission mode. The basic one is speed. So, if you have got no other factors impacting our transmission, then parallel transmission can increase the transfer speed by a factor of n, where n is the number of bits that we are sending at the same time. Students, the disadvantage, as you would have already guessed, is the cost. And why the cost? Because we need n wires to be running from the sender to the receiver. So although we managed to get higher speed of transmission, we have got relatively more expensive technique in parallel transmission, and therefore because of this disadvantage, we normally limit the applications of parallel transmission to short distances only.